Today we have an esteemed speaker, Laxmikant Tiwari sir, with us, who will guide us throughout the workshop how we can develop an application on agentic AI. Thank you, sir, for accepting our invitation.
It's my pleasure. Yeah, thank you.
Okay. I would like to have a brief introduction of sir. Lakshmikant Tiwari sir has 10 years of experience in advanced analytics and machine learning area. He has done M.Tech from IIT Kharagpur and he is currently leading
Suja
Suja,
ma'am,
you are on mute.
yeah, I think you have been.
Okay.
Okay.
Okay. So am I audible now?
Yeah, you are.
Hello.
Yes.
Yes.
Okay. Okay. So yes. I
All
would
right, I
like to.
think now I can start. Yeah, thank you so
Yes,
much.
sir. Yes, sir. Okay.
Yeah. All right. Hey, everyone. So, don't worry. I won't take more than 1 hour. So you guys will not feel like bored, right? So before 6 p.m., I would definitely finish this. Don't worry if you have evening plans. All right. So I have shared here some links for your reference. SQLite database link. That particular database we will be using with our agent. And the code which we will be doing today, that is also available there at the GitHub. You can get that Langchain V1 project. And the large language model link is also provided there, the Quen 3. So the Quen 3 is one of the latest model. It was released by the Alibaba. The performance of the Quen 3 is so good that it can compete with the OpenAI models. I'll be using here the Ollama. So the Ollama, you can say that this is like the local LLM inference the service. And in the Ollama, we'll be using this Quen 3. So let me just quickly give you the background, how the Ollama and all these things are going to work here. So you can say that this particular thing is going to be the Quen 3 model. And we are going to use here a 30 billion parameter model. Uh, just a second. Move it here. Quen 3 is here. All right. So this particular model we will be using here, the Quen 3. So as the large model you use, the more power you will get basically. That is the fundamental here. And currently I'm using here a 32 GB GPU here. All these things I'm telling you why, because you see, once you start developing your own LLM application, let's say you want to develop a local LLM application, and you have some privacy concerns, etc., then obviously you have to use some local LLM instead going through the chat GPT or some online LLM where you send your data outside of the network. All right, so here we have a GPU that is the 32 GB GPU. It is RTX 5090. Let me just write here for your reference. Being as a computer science engineer, I guess you guys should know that what kind of GPUs are there and how much GPU you need for a particular model. So how you are going to decide that which particular model you need to use for this GPU, RTX 5090. So for 5090 here, I have chosen this one. So the model size is 19 GB here. So you can say that the model weight itself is a 19 GB here, and plus some additional things, you can say that like it will not go beyond 28 to 30 GB. So this one plus 1.5. All right, so that is the standard. So we can say that within the 30 GB, this model will perform better for us. So here you see currently we are not consuming any GPU, but later on, once we load our model, then you will see that this whole 32 GB GPU will get filled up here. So later on, I'll show you that part there. All right. So this is your Quen 3 model here. And then on the top of this Quen 3 here, we are using our Ollama. All right. So this is your Quen 3, and then you have your Ollama here. Let me just see how it can go back. All right. Let's say this is your Queen3. So this is your Ollama. Outside of this Ollama, we will be calling our model using the Langchain basically. Let me just make it a little bit larger. Yes. Then there would be a Langchain here. So this Langchain will be interacting with your Ollama, and then Ollama will be sending the output. So what we are going to implement in the Langchain, we are going to implement here agent. So what is the agent? Agent is nothing like just your LLM, and then it has some workspace. Along with that, it has some additional tools. That is all thing it has. So you have your LLM here, and that is the Queen3, this one I'm saying. Now I'm saying this is LLM. So LLM is this overall brain. After LLM, you have then the tools here. There are so many tools basically. If you connect your LLM with this tool, so basically there is a connection between this LLM and the tool. Now LLM have the access these tools. So LLM can perform the operation apart from what it is trained. So let's say if your LLM is trained for generating the text data only, and it is not good in the mathematical operation, or it is not good in accessing and analyzing the database systems, then you can add there a tool which can access the database, which can analyze the database. So basically LLM can call these tools, and then it can ask to do the required operation. So this whole thing, once you connect together, all right, all these things, then this whole things together becomes actually the agent. So this is the overall funda for the agent. All right, so this is something which we will be designing here. In our case, what we are going to connect with these tools. So we'll be connecting here the database basically. So we'll be having here our database DB. And in this DB, we are going to have our employees database. This is one of the standard database generally we use for in our computer science so many times or so many cases. So this is our employees database. So LLM cannot connect directly with this employees database. It don't have that particular power. It cannot connect. No matter how large LLM model you use or how good LLM model you use, it cannot connect with that. How it is going to connect with that? It is going to connect through this particular tool. All right. So in this tool, we are going to have so many tools. All right, so many tools. So how many tools we can have here so that we can have a full functionality here? The tools like getting the schema of the employees database, like how many tables are there, how many fields are there, the type of fields are there, all these things. Other than that, we can have one tool which can prepare our text to SQL query. The another tool we can have that which can actually check whether particular formulated query is a valid query or not. The one more tool we can have here that whether a particular generated result is valid or not. So all these things we can do. Let's say if query is executed and it got error, then your LLM need to correct those. So these things we can do. Okay, let's go ahead and try to understand this with some presentation here. So I have prepared here a presentation. So this is our SQL agent, as we understood here that this whole thing is our SQL agent, and these are the tools here. So we are going to get our database schema. It is going to get all the table structure with the column and the field information. Then it is our LLM is going to generate the SQL query. Once it gets the whole database schema and understanding structure, etc., then it can generate the SQL query. So how the table schema look like? I'm sure you guys must have gone with the DBMS course. In that, you guys must have gone through with these tables and these things. So how it looks, let me just show you quickly here. This is one of the previous execution. Here I'm going to show you somewhere we must be getting our table schema. So it is going to look like something this. You have, let's say, the department. In that department, you have these many fields. Thereafter, you have another table like the department employees. These are the fields here. So once your LLM get these fields, only then it can prepare a correct query. Otherwise, it cannot know that how many tables are there, what are the fields there. So you have to provide all these to your LLM. Once your LLM gets that, then it can prepare a SQL query. Apart from that, one important thing here you will see, that is the SQL select. LLM, if you do not control LLM or the agent especially, if you do not control your agent properly, then it can do so many things. And in that so many things, it can do a lot of things which can actually harm you. Like it can delete the data, it can update the data, it can insert the new data, it can do anything. So for that purpose, what we have to do, we have to provide there a proper validation so that it can execute only select operations. So basically, it can read only your database. It must not have any update, insert, delete, or truncate. Any of these access your agent should not have. So we validate our SQL query. Once we validate that everything is good and fine, thereafter we execute our SQL query. Once we execute our SQL query, then there could be a chance that it might give you the error. In that case, what happened? We have to fix our SQL query. The last one is the analyze query result, although it is not needed, but I have just included here in case, let's say if you want to further analyze your query result and you want to infer that, like you want to do some interpretation, in that case, you can use this particular tool. Otherwise, it is not needed. So this 5 tool is actually the more than enough for you. And we have told we will tell our LLM that call these tools in a sequence, but it is not guaranteed that it is going to call all these tools in a sequence because it is LLM. All right. It cannot, it will not follow your instructions all the time. It's not guaranteed the 100% of the time. So there could be so many times where it may not call get database schema. It might call directly generate SQL query. Then it might directly call the execute SQL query. And then finally it produces the result. It's not always guaranteed that it is going to follow all these. So that is something which we have to aware, and we have to be ready for that particular, the problems with the LLM or the agent. Not just this Quinn 3 models, but I'm saying here that any kind of the LLM. So this is the overall workflow process. As I told you that it is going to get the schema, and then the query is going to be generated. Then the safety validation is going to be done there, the query execution, error handling if needed, otherwise the final result analysis. All right, that's all. So this presentation is also included here with our code file, the link which I have shared earlier here. Lakshmi made it, Langchain V1 project. You guys come here and you can start it or fork it so that it can, you can save this in your GitHub repository. Or you guys can go here and just start this. All right. So that you will actually get the access to this repository easily anytime whenever you want to see this. All right. For the Ollama, let's say if you're a super beginner, I guess many of you might be here, the super beginner who do not know about the Ollama or anything like that. Then for you guys here, actually there is the playlist here at my channel, this local LLM tutorial. Let me just share this so that you guys can follow along for the local LLM. Let me just write here so that we can get started here. Local LLM Ollama basics. All right, having said that, let's go ahead with our project here. Just a second, give me 1 minute. So we are using here Langchain version 1. And if you go to their site here, Langchain documents, you will notice here that currently we have a Langchain version 0.3. All right. So why we are using Langchain version 1? because Langchain version is going to be launched in the month of the October. So maybe by the time you guys watch here, then you guys will be getting this Langchain version 1. All right. So Langchain version 1 brings a lot of performance improvement over the previous version, but there is a special requirement to install the Langchain version 1. So you have to apply there this particular flag here, that is the pre. All right. So the pip install Langchain, Langgraph, all these things you need to install, but with the flag that is the pre. So with this, it is going to install the latest version, that is the alpha version of the Langchain. Why I'm using this? Because you see, by the time you guys make your project, you watch this, you revisit this project, etc. By that time, the Langchain V1 will be coming there. So there is no point to going with the previous version, where if you run the code, then it will start throwing the error. All right. So you have to install your Langchain with this particular method. Otherwise, what will happen here? You will get the error because there are so many tools and the methods which we will be using in this particular lesson that might not be available with the previous version. So this is something which you have to do. Once stable version is released, then you can use as a regular installation method. That is this one. All right, perfect. Now let's go ahead and start importing, first of all the necessary libraries here. So some of the Python packages we need to import, which we are going to use, like the regex. So this regex we will be using here. Let me just bring it here so that we can do, we can also see our workflow process and we can know that which particular the tool we are currently implementing. So this regex, we will be using this regex heavily during our safety validation. All right. So why regex is used there? Because regex is very efficient to find a pattern there. So we will find out all the pattern like the select queries only generated, insert, update, truncate, all those things are not generated. For that, we will be using there the regex. Thereafter, once you have installed all these things, then you can import the chat Ollama. So why we are importing the chat Ollama? Because we are going to use here the Ollama. All right, so this one. So here is the Ollama. Nowadays, if you install the Ollama, you will be getting like ChatGPT interface here. So this is something where we will be using our Ollama. All right. And let's say in worst case scenario, if you do not want to use the chat Ollama, then you can actually import chat OpenAI itself from the Langchain _OpenAI import chat OpenAI. So basically, this is something which you can import from the Langchain OpenAI if you want to work with the OpenAI. All right. Then we import SQL database so that we can connect our LLM, basically our tool here. Let me just show you here. So basically we can connect our tool with the database. All right, let me just close this one. Thereafter, we import here a tool so that we can implement all these methods as a Langchain tools. Then the system message will be implementing a system message so that we can tell our LLM that follow this particular workflow process. And then we are going to use here the create agent. So this create agent, we are importing from the Langchain right now. If you guys have used the previous version, then you might have been importing it from the langgraph.prebuilt. Since we are using Langchain version 1, so in Langchain version 1, it has been actually placed in the Langchain agents. Once this thing is done, the one more thing you will notice here that we are also going to trace our execution on the Langsmith. So for the Langsmith, you can come here, smith.langchain.com. Then you can come here in the setting. Then you can go here in the API key and you can generate a new API key. For that, we are actually setting our API key here using our environment variables. So we are loading our environment variables. Environment variables are loaded here. One of the example is here. So .env example, this is how you are going to create this .env file. There you will be having Langchain API key, which you will get it from here. Thereafter, this is standard. You have to put it as it is. And this is the project name, that is the agent here. As you see here, we are currently seeing the project that is the agent, this project. All right, if you click this, and then we can see all the trace which we are going to run. Sometimes back, I ran some of the queries. Now you can see all those are actually here logged. this is important because with this, you can know that how your agents are doing behind the scene. As you see here, this particular agent, how it is doing. So every time this agent is executing, it is calling some tool here. So first time it got executed, it called this tool. The another time it called this particular tool. Then again it got executed. So basically what is happening here, when your tool executes, then it returns the result to the LLM. Thereafter, LLM decides that which particular tool now it needs to call next, whether it need to end the process, so basically produce the final result. So here you get either your final result or your LLM is going to call the tool again. So this is how your LLM decides there. Let's go ahead and execute this. So with this, we have imported this .env file variables in our environment here, and you can see it is the true. That means it has loaded successfully. Now we are going to do here a database setup. So our database, I have placed that inside DB, employees.db. This is the same database which you have here at the GitHub, employees SQLite, DB SQLite. You download it, unzip this. After unzipping, you have to rename your database to the employees.db. All right, so you will be getting this particular whole name here, but you just rename that. All right, and then you put it here in the DB. All right. Let's go ahead and set up our DB. So we'll be using this SQL database from URI, SQLite DB is our folder. This is where we have placed our employees.db. Then we read our employees.db here. We get our DB. Thereafter, let's go ahead and check the connection and get some basic information from our database just as a sanity check. So that we should be knowing that our database is working correctly. Our database have proper data or not. So for that purpose, we get here list of the tables. All right. So db.get usable table name. So basically, this is like a schema. So it is going to get all the table name here. All right. Then we are printing here that how many tables are found. Otherwise, in worst case scenario, we are just printing here the exception. All right. Let's go ahead and execute this and then see. So as you see, there are 6 tables: department, department employee, department manager, employees, salaries, and the title. So these are the 6 tables. Let's go ahead and see how the schema look like. So you can just simply run this. This is how your schema look like. So this is the schema which we will be passing to our LLM so that LLM can understand that what are the tables and what are the fields are there. All right. So your LLM gets all these schema, like it has the table and all these fields are here. Then again, another table, department employee here. There was the departments, department manager, and then these fields are there. Then you have employees. There are so many tables. Basically, 6 tables are there. So this is the schema. This is how the schema look like, basically. All right, so we have successfully connected with our employees database, and we know that our employees database have some table there, and also we know that there are schema, so it has some data there as well. All right, having said that, let's go ahead and do our model setup. So here we are going to use our chat Ollama as a local LLM, Qwen 30 billion model. You can choose any model depending on how much GPU you have or how much processing power you have. If you have a very low GPU or very less power in your computer, then you can use this one as well, 0.6 billion. This is a very small model. Even if you have 1 GB of GPU in your laptop, then it can work properly without any issue. Although this might be having some problem in the calling the tools, but basic things you can get working properly without any issue. And then the base URL, this is where our Ollama is currently running. If you open this here in the browser, you can see that your Ollama is up and running. That you can verify here, our Ollama is up and running here. By default, the temperature is set here, the 0.7, I guess. That's the default temperature. Let me just see it quickly here. Seems like it is not set there, but the default temperature provided by the Langchain, I guess that's the 0.7, but here we are setting it to 0. so that it can produce the facts instead of getting hallucinated. Let's go ahead and try to see if we can connect with our LLM. So this is how you can connect LLM.invoke, and then we are going to see some result here. The one thing I also want to show you here that as we are loading our LLM, you can see here the GPU memory is getting utilized here. Earlier, it was almost nothing, but now you can see almost 30 GB GPU here, as you see. Almost 30 GB of the GPU is getting utilized, and some execution was done here at our GPU as well. Let's come back here. As you see, this is the output. So one more thing you will notice here, a think tag. So this Queen 3 model is a thinking model, basically. All right, so the thinking model is quite good model. Basically, they provide a lot of the reasoning here. So you see, this can call the tools. This is also a thinking model. If you want to see here how many thinking models are there, come here. And then you can just simply click on the thinking. Then you will see the list of all the thinking model which can actually reason or which can actually think here. So the thinking model always produces better result than the normal model. Why? Because the thinking model first thinks before responding it. All right. So it thinks here that, okay, the user greeted me with hello, how are you? First, I need to respond politely, etc. Then I need to do this. Thereafter, wait, user might be looking for a quick chat, but as AI, my main role is for assistant, etc., etc. So it first try to understand by itself that what it need to do. After doing a lot of thinking by itself, then it finally creates here the answer. So this is the final answer. After thinking this much, then it produces this particular final answer. As we move ahead, once we see that how it is converting your text data into the SQL, there we will also see your model will do a lot of thinking here. All right. Now we have done with the setup of our DB, and also we are done with our setup of the LLM. We have connected successfully. Let's connect with the SQL tool here. So one tool at a time we are going to implement. First, we are going to implement our database schema discovery here. So what we do here, get database schema. So this is docstring. This is very important. So this particular docstring, based on this docstring, your LLM will decide that which particular tool it need to call. All right. So the one thing also I want to tell here before we move ahead, in fact, so this LLM we have implemented till now, agent is not implemented. You just need to be aware with that. Agent needs here three things basically. Let me just write here. Agent needs here a prompt, that is the system prompt, which we will implement later. It needs here LLM. LLM we have implemented. And this also needs here the tools. Once you provide these three things, then this whole combination will become the agent. So we have implemented our LLM. Now we are implementing the tool. Once this is done, then we will implement our prompt. Then our agent will get created. Okay. So the database schema is here. This is very important. As I told you that with the help of this docstring, your LLM will decide which particular tool it need to call for a given query. Thereafter, so you see one thing here, this database will be connected with the LLM. So LLM can pass the table name. So this tool is going to return only table schema. Otherwise, if LLM does not pass the table name, then your LLM is going to return, basically this tool is going to return whole database schema. So as we move ahead here, you will see db.getTableInfo. So this is the schema here. All right. First, we get all the table here. Thereafter, once we get all the table, then we decide here that the table name, which is passed by the LLM, that is present in the database or not. If that is present, then it is going to return there for that particular table. Otherwise, it is going to return here for full of the, you can say this is schema, which we had printed earlier. Do you remember here the schema? So it is going to return here for whole database. So the two things are getting implemented here. First, if table name is passed, then it is returning schema for that particular table only. Otherwise, it is returning for whole database basically. All right. By the way, guys, in between, if you have any queries while going through, so I guess you guys can ask that as well. Otherwise, we can keep it for the last. So you can keep the note that if you get confused anywhere. Okay. Thereafter, you have generate SQL query. So this particular thing we are going to implement here. And this thing, what you see here, this is known as a decorator. All right. So this decorator is going to convert this standard Python method as the LLM tool here. And generate SQL query is going to accept here the question, that is the must parameter. And then the schema info is actually the optional. All right. So if schema info is passed, well and good. If it is not passed, then don't worry. Your LLM is going to generate the SQL query in any way. Later on, it might get the error, but it is going to generate. And this is the doc string. So with this doc string, your LLM is going to know that when it need to call this particular tool. All right. So if schema is provided, then it is going to use the schema. Otherwise, it is not going to use the schema. Now, we are going to prepare here a prompt to generate the SQL query. Remember, this particular prompt is not this prompt. This is the agent prompt, which we will implement later on. This prompt is actually the tool prompt, query generation tool prompt. All right. Where is that one? This one. All right. So we have, based on the given database schema, if schema is provided, generate SQL query. To answer this question, rules are this: use only select statement, include only existing column and table, add appropriate where, group by, order by. Let's say if you are trying to do the filtering or aggregation, then it need to do the group by there or where clause. Then also we say that return only 10 rows unless it is specified. So unless I tell me a top 50, it is going to return you only the top 10 results. And then return only the SQL query, nothing else. So this whole thing we tell to our LLM, and then we are going to invoke our LLM. Remember, this is our SQL query generation. All right. This is not the agent. So this is the tool. In the tool, we are using the LLM. So here, as you see, this LLM is a different LLM. This is like a coordinator or the main LLM. In the tool, you can also have the LLM. So basically, one LLM can call the another LLM to do some task there. So that's the same thing is going to be same thing is actually getting done here itself. So the one instance of the LLM is calling the another instance of the LLM to generate the SQL query. Once query is generated, then it is going to return. Otherwise, it is going to return appropriate result so that it can call error handling. This one, right? Fix SQL query error tool to fix the SQL query. Okay, let's go ahead and execute this one. Get table schema. We did not execute. So we execute this one. Thereafter, we execute generate SQL query. Then we are going to use here validate SQL query. So this one, safety validation we need to do. As a decorator here, we provide our tool, then validate SQL query. It is going to get the query which is passed from here. And this is going to be used for our LLM so that LLM can know that which tool it need to call for the validation of SQL query. Thereafter, our query is getting printed here, but remember, only top 100 character is getting printed here. That's all. Okay. And then we strip our query. So basically, you see, your query might be having here some special characters, new lines, additional space. Remember, before or after. So basically either a prefix or the postfix, not in between query. It's not going to strip in between query things, only before or after the query. All right. So it is going to strip. Thereafter, we are going to remove, basically we are going to clean our SQL queries here. So sometimes your LLM might generate your SQL query, which might be having SQL and then query or some, extra or additional space. All these things are going to be removed using the regex here, right? So that is why we had imported the regex, the first thing there. Then we finally clean the query again. Thereafter, we are going to check here how many blocks are there in our query. So you see here in SQL query, generally what we do here, if you have your SQL query, so let's say some random SQL query here, I'm just going to write here, select everything from some table and where maybe ID in something like that, XYZ or 234. And then for one statement, we put there the semicolon like that, all right? So it is going to find out that whether the query ends with the semicolon or not. All right. If there are multiple semicolon, that means it is the multi-block statement. So for multi-block statement, it's going to reject there. So basically, it is going to say that multiple statements are not allowed. So LM need to actually need to produce only the single statement. All right. Now, as we move ahead, clean query dot r strip. So now we remove this semicolon. If you have just a single block, all right. Thereafter, you have here must select only. So this is the thing which I guys told you the first thing there. We need to be ready here with our LM, with the some kind of the protection for our LM. Otherwise, there have been many instances where people have actually deleted the whole database or whole server, etc. Right? So there have been catastrophic instances in the world where unwanted result was happened or achieved. You can say that by the agents if a proper guardrails are not placed there. So we have to make sure that here only select queries are allowed there. So these queries are dangerous query, like the insert, update, delete, alter, drop, create, replace, truncate, execute. All these things we are going to remove. All right. So these are the dangerous patterns. So we are going to identify in our SQL query whether we need to remove these or not. Yes, obviously, we can reject these queries straightforward before executing. So we reject these query before executing. All right. So here it find out the pattern, then it says that unsafe SQL pattern detected. All right. So it is not going to allow the execution. All right, once all these things are done, thereafter, let's go ahead and validate with some basic syntax where we say that our query must start with the select statement. All right, that's what we are doing here. If it does not start, then we say that, okay, multiple select statements are there. Basically, in fact, here we are actually counting that how many selects are there. So sometimes what happen here, there are many ways to write SQL query. Basically, you can write SQL query in between SQL query as well. All right. So basically, you can write here another SQL query, let's say like this here. Select star from some other table, maybe like this you can write. So basically, now this is going to be executed in the result of this one. So this one will first get executed, then this query together will get executed. So that part we are not going to do here. So basically we say that if there are multiple select, then we are going to reject it straightforward that multiple statements are not allowed here. Thereafter, we are going to check here the valence parenthesis that if there is a where statement or group by etc. in that balanced parenthesis have to be there. If everything is done well and good, then we validate our query that, okay, it is valid. We pass it with the prefix that it is valid. Later on, before executing, we will remove this valid. All right. All right. If in worst case scenario, let's say some exception happens, then we are going to return this error. This is very important. All right. So always remember, guys, if you are implementing a tool, if you are connecting the tool with your LLM, then it is very important that you connect your tool with a proper error message. Otherwise, your LLM will not know that how it need to handle that error. So once you return this proper error, your LM will know that what error is there and how it need to handle. Perfect. Let's go ahead and execute this. Now we have implemented these three tools here. All right. So we have implemented schema discovery, query generation, and safety validation. Now we are going to implement here the query execution part. Okay, let's go ahead and implement query execute. It is pretty much simple, straightforward basically. We just need to pass here a query. Thereafter, as usual, I guys told you that there is the doc string. The doc string is going to be used for the LLM. All right. Thereafter, we just clean our query once again. Thereafter, we are going to check if this query is coming from this validation stage where we have prefixed our query with the valid. In that case, we are going to remove this valid and then we are going to get the clean query. All right. So basically, it is going to say that if this query is coming from valid, only then execute these parts. Otherwise, move ahead straightforward. Here again, in worst case scenario, let's say if query before calling the execution, query execution, safety validation was not done, where these SQL or all these are not removed. In that case, we have to remove these separately. So we are removing these again here. Once everything is removed, then we are ready to execute our query. So this is how we execute our query. We have already got our DB. So you just need to write there the db.run, then the query. So with this, it is going to produce your result here. So the instance of the DB we have already generated here. All right. So in this instance of the DB, you can just simply write here like this query here. In fact, you can write the db.run and then you can write here your query like this. Select everything from, I guess, employees was a table. Limit 1, I'm just going to do here. If you execute, you are going to get the output like this. All right. So this is what your tool is doing here, execute SQL tool. So db.run. All right. The clean query is there. Then it finally produces the result. And then we are going to validate our result here that if result is present, then return it. Otherwise, say that, okay, query got executed successfully, but it returns no result there. And then finally, raise the exception if there was any error while the execution. So how the error can come? Let's go ahead and try to provide here some table name which is not present. Let's say this one. All right. So it is going to throw this error. So it is going to give this error to your LLM that no such table like this employees or something like that. So your LLM will know that, okay, in the query somewhere there is the table that is not present. So it can call the schema and then it can correct or fix the query again. So this is what it does here. All right. So that's what we do here, employees. Okay. Having said that, let's go ahead here. We need to come here again. Let's go ahead and execute this. So we have executed this. All right. Perfect. All right. Guys, just give me 1 minute, guys. I'll come back. All right. Okay, so we have got our execute SQL query tool implemented here. Now we need to implement our another tool that is the error handling tool. That is the fix SQL error tool. We come here and we pass our original query. Along with that, we pass our error message, the message which you had seen previously, like this particular table is not there available in the database. That is the one kind of error. You can get so many type of the error, right? Maybe your query is not correct. It's not formulated well or like that. And then the question also comes there so that your LLM gets complete context that what was the question, what was the original query, and what is the error. Once it gets all these things, then it can properly fix the error there. All right. So we pass this, fix the failed SQL query. So basically, this is the doc string which LM will use whenever error comes. Then LM knows that this particular tool it need to call. All right, we provide here a prompt. The following SQL query failed with this original query with this error, and here is the original question, and here is the database schema. Now you need to analyze, fix it, and your query, whatever reformulated queries are there, you need to make sure that it still answers the original question. It should not do like, okay, I have fixed the query, but it is not answering the original question. So here we are saying specifically that it must answer the original question, and it uses only the valid table and the column names and follow a SQLite syntax rule. All these things we tell to our LM, and then finally we invoke our LM. Then finally we get our fixed query. Once fixed query your LM gets, thereafter it can again call your tool, that is the execution or validation tool, depending on the LLM. All right, whatever the tool it decide to call there. All right, perfect. Let's go ahead and run this tool. Now we have reached at the stage where we are going to implement our last tool, that is the result analysis tool. This tool is although not necessary. So just for the completeness, I'm just gonna tell you here that where question will come, final result will come, the query will come here, and it is going to convert your SQL result into the proper answer. Basically, it is not needed, but still for a completeness here, I'm implementing. So here it is going to have analysis prompt. This is original question, SQL query, and there is the result. Provide a clear natural language answer. So basically, it is like the interpretation. It gets the query, it gets the result, it gets the question, and then it interprets that, okay, this was the question, this was the result, so this is something. Basically, it is just going to interpret the final result. That part is not needed because the LLM itself can interpret the result. For that particular thing, we do not need the tool. And for completeness, I have just provided that. Now we are going to implement the system prompt. Let me just come back here. So we have implemented here what? We have implemented the LLM, we have implemented the tool. Now we are going to implement the prompt. Once we implement this one, then we will be calling our create agent method. In that, then we will implement our prompt. All right. We will implement our agent there. So this is very detailed prompt here. Like you are an expert in SQL analyst working with employees database schema is here, your workflow for answering the question is here. So use these tools like database schema, generate SQL query, validate SQL query, execute SQL query. If there is error, then call this one, otherwise call this one for final answer. Then these are the rules. Always follow the workflow step by step. So we tell our LM that follow this step, but it's not guaranteed our LM is going to always follow that particular step. Thereafter, we say here, if query fails, use the fix tool and then provide clear informative answer. Be precise with the table, handle errors, etc. All these things basically we are telling to our LM to follow along. Okay, once we have our prompt, now it is time to create the agent. We are going to create our agent here. So in the agent, we have connected our database schema, generate SQL query, validate SQL query, execute SQL, fix SQL. This particular thing I have commented out. We do not need the analyze query result. Once you have the tool, now we have everything. We have a tool, we have LLM, we have a prompt. We can simply pass all these to our agent. So we are going to create our final agent. So basically this agent is
So you gone mute now. Hello. Hello, sir.
Yes, yes.
Ah,
Is it fine
yes,
now?
yes. Yeah.
I was muted since last 5 minutes, or
No. Just 1 minute. Just 1 minute.
oh,
Previous.
so this one I need to explain again. This one. Okay, guys,
No,
have you heard this prompt one? Okay, let me explain this again quickly. Although I had promised you guys I'll finish it by 6, so I might overrun by 1 or 2 minutes anyway. So this is the prompt. We are going to provide this prompt to our LLM so that our LLM can, call the tool in this particular sequence. It is always not guaranteed. It is going to follow this sequence. And here are the rules which we have provided to our LLM that these are the rules. And then finally, we tell our LLM that these are the available tools so that you can use these tools for these purpose here, like the table structure, etc. And then finally, we prepare the list of all the tools. This tool we are not going to use here. And as I have told you previously that LLM needs all these things together. So we have got the prompt, we have got the LLM, we have got the tools. So we are going to give all these three together to our agent, and then we get our SQL agent finally. All right. Now we have got our agent. We have successfully created our SQL agent here. Now it is time to see how our agent look like. So this is how our agent look like. All right. So you have your agent, then there are the tools. Your query comes here. It goes to the agent, that is the LLM. Then it is going to call the tool, or it is going to end the process depending on the final answer or the result returned by the tool. We ask the question here. It decides it need to get the schema. It calls the schema tool. It returns the result. LLM again decides that, okay, I got the schema. I need to generate the query. It generates the query. Then it validate it. Then it execute. After execution, it gets the result. Thereafter, it actually generates the final inference or interpretation. And then finally, it moves to the end. So this is how overall agent works here. All right. Let's go ahead and implement our query function where we will be asking the question basically. So ask question here. Then we are just going to print here some nice formatting. Thereafter, we are going to use our agent into the stream mode here. We pass our question here. So the question comes, let's say, like we ask here a question that how many employees are there in each department? Like human resource department is there, production, I think the technology, management, whatever departments are there, we can ask the question that comes here, then your agent start answering that. Thereafter, we are going to get the last message here. So event messages, last message. Let me just quickly show you why we are taking the last one here. So your state is going to be like this. In that, you will be having there the messages. That is the key. In that messages, you will be having a list like this. In the list, last message is always the final answer here. So this is the last one here. All right. So the last message is always the final one. That is why we are going to get the last one here. Thereafter, we are going to see here if there is any tool call. All right. So basically, if there is any tool call like this, let me just show you here. If there is any tool call like this, then it is going to say that, okay, here is the tool call, and here is the tool call, the table name, which the tool name, which it is going to call. All right, perfect. So it is going to just print so that we can know that overall the process, what is happening behind the scene. And final answer is going to be printed here. Let's go ahead and execute this. Now we are going to chat with our SQL. So in this SQL, what we'll do here, basically we are going to get the question using the interactive mode, using the input here. So we'll be giving our question, then it is going to take the question, then it asks here with the ask SQL. If we pass quit, exit, or the queue, it is going to exit the mode. Otherwise, it will keep asking the question, and it will keep answering as we ask the question. That's all we have to do here. Let's go ahead and ask the question here. So the first question I'm going to ask here, in fact, wait a second. Let's go ahead and run this. All right, now here you see you got here this pop-up. So the first question I'm going to ask here, how many employees are there in each department. Let's go ahead and run this. As I run this, you see your SQL agent has started here. This is my question. Now it is generating the answer for this particular query. As you see here, it has started utilizing my GPU and the model has been loaded in the GPU. It is utilizing almost the 30 GB of the GPU. All right. And the model is utilizing like maybe 80 to 90% of the GPU. Overall utilization is being done there. And here it has started generating the answer. As you see, how many employees are there in each department. First, it is going to get the database schema. You see here how good it is. So first, seems like it has follows the instruction, although generally the people don't do that, but at least the LLM is doing that. So the schema discovery here. All right. So first it calls the schema. It gets the schema. All right. So this is the whole schema. It got all the schema here. Let's go ahead and see this in scroll mode. It has got the schema. So this schema will be passed to the LLM later on while generating the query. All right. So this whole schema, the next time your LLM is now generating SQL query. So now the LLM calls query generation tool. In fact, this one, generate SQL query, it calls this one. Now the question was this: how many employees are there in each department? All right, the schema info is this one. So it has passed this whole schema and then it is generating. Now you see here in the think mode, it is thinking too much. All right. Let's see, the user wants SQL query to find how many employees are in each department. But wait, problem says how many employees are in each department. So the department, it need to get the department using from departments table, etc. Should have count employees, department employees. See here. All right. So basically, if you ask something to do to a human, then the human first think that what it need to do. So what it is doing here, that it is just thinking here that first it generates this query. Thereafter it validates automatically that, okay, the problem says limit results to 10 rows unless specified. This we have already specified in the prompt. That is why it is doing that. So our execution is already done. As you see here that if you put here the queue, so it is just going to interrupt that. All right. Thereafter, all these things, as you see, thinking too much, basically, it is generating all these the SQL queries so many times for validation that whether it is in right direction or not. Then finally it says that here, yes, this should work. So the final query is above. This is the final query. So what it does here, it takes the count. So this is something which is good. So it takes all the department name. Here's the count from the department. It joins the another table. And thereafter, it utilizes here the group by, order by. So you see here, using the group by, order by, and the join, all these things are quite complex here. But still, our LLM is able to do all these by itself without any manual intervention. Thereafter, it calls here the validate SQL query. So as expected, it is now checking the safety here. So it calls here. Then finally, it says that the query validation is passed here. Thereafter, it has this final query where it starts with the valid. So your execute query removes that valid. Thereafter, it finally executes. So it says that query execution was successful. Then finally, this was the answer. So in development department, it has this many people. In production, this many. In the sales, this many. And here, all these things, you have here the answer. And this is the final answer. So this is the interpretation. The department and their current employees counts are follows, order from the highest to the lowest. You see here how good your agent is. It is able to interact with your database. So this is one of the simplest example. Now you can implement this in the production. You can connect with your database. Let's say if your college database or your project database, there you can just ask the question in the natural language. Your agent can automatically go and connect with the database. It can identify all the relevant tables, schema, all those things. And then finally, it can returns the result here. All right, now you can ask any question, whatever the question you want to ask. Let's go ahead and run this again and ask the another question. Okay. I can here ask that, show me average salary of employees department wise. So now it is going to again construct here a very complex query where it is going to use the group by and then the average for each employee for each department. And then it is going to produce the average salary the department wise. In meanwhile, while it is doing all these process again and again, as you see here, all these things, let me just show you the tracing here at the Langsmith. So this particular thing is getting executed. This is the latest question. Show me the average salary of employee department wise. And this was the previous trace which we had done. How many employees are there in each department? So here your agent, first it calls get database schema. And then again, the result goes to the agent. Then agent decides that here it need to call the generate SQL query. The one thing you will notice here, the should continue here. So this should continue is something which actually decides that here whether it need to call a particular tool or it need to exit. So here there is the condition. So that decides whether it has got the answer or it still need to call the tool or it need to process the question. So that should continue is doing here. In fact, here you will see our execution is done. Now it is asking for the another question. All right, let's come back here again. So after database schema, that result comes here. The agent decides, it calls the generate SQL query. Thereafter, it calls here the validate SQL query. Then the execute SQL query is called here. And then finally, this final result was produced. This was the query here. All right. So this query, if you execute separately, you should be getting the same result what we are seeing here. If you execute that query here, let me just quit this. And then we can execute our query using db.run. I guess that was db.run. And then if you pass this query and you execute, you should be able to get the same result, what we were seeing there. So this result is then passed to your LLM. LLM produces the final result. All right, as you see here, then the final result is produced. This agent comes here. Then finally, this should continue decides that I do not need to continue because I have got the answer. Then finally, it goes to the end here. So here you see here output end here. All right, so this should continue. Then the should continue output end means your execution is going to be stopped because it has got the answer. Now you see here above execution is also done here. All the tracing is available here. If you check here, the should continue. Let me just see that here if it has end or what here in this particular should continue. It says that no, you need to call the tool here. So there is the tool call. All right. So this particular tool call was made here in this should continue, in between should continue. But here in the last one, you will see here that it goes to the end here. All right. So this is the end here. Let's go ahead and quickly come here. This one is executed and this is the result here. So the customer services gets this much, finance gets this much, and then you have all these here, sales gets this much. Human resource seems like human resources gets too less here. All right. So the HR people only give a lot of salary to the employees, although they are getting very less. So the finance people are getting this much, and then the marketing people are getting this much. All right. So you see here that it says the sales department's the highest one, 80,000, 80K per employee. This is the average salary. All right. Perfect. All right, guys, I hope you guys must have understand this whole process. Let me just quickly recap this whole thing. So this particular with this particular project, we have gone here with the SQL agent with the Langgraph. The presentation is also included here. In the VS Code, if you want to see it in the preview mode, then you need to come here in the extension. Here you need to make sure that you have installed the HTML5 preview. All right, so this one, HTML preview, make sure you have installed this. Once you have installed that, then you can preview your HTML code in the VS Code itself. Other than that, this particular code is actually pushed here at my GitHub repository. You can directly get it from there. You can just simply download this at your computer and then you can start executing. The one thing is missing here, that is the DB folder, because the DB was quite large file, so I did not push here in the repository. So you have to just create a new folder here in your computer, and then you need to download this SQLite database, rename this to employees.db. Make sure to extract this first, because this .gb gz will not work. You have to extract this. Let me just see that if it is available in my download directory. Yes, it is available here. Let me just quickly show you here. Once you download and extract, you will get it like this, and then you have to rename it like employees.db, then copy that and paste in the directory there, like I had just shown you here. All right, in the directory, then you can start executing all these one by one. If you do not have the chat Ollama, then you can use the chat OpenAI. That's the only thing you have to make here a change here. Only here. All right. So you don't want to connect with chat Ollama. Don't worry about that. You can just create LLM equal to the chat OpenAI, select your model, provide your API key. So this is the only line of the code which you have to change. The rest of the code is going to be exactly same. There is no change in the code. So that particular thing only you need to change. Other than that, let's say if you have missed something in this course, anyway, the recording was done, but still, let's say if you have missed something, then here on the YouTube, I have recently uploaded for that particular course, that is the Langchain V1 project. You can get this one. The fourth project, that is the SQL agent with the Langchain. So I'm just going to get this one and then I'm just going to paste it here. Let me just quickly paste it here so that you can guys bookmark this. All right, perfect. And also do not forget to star or fork this repository so that whenever I upload this, the new project here, you guys can get the update directly in your GitHub that some error or let's say some error comes later on or some new release comes. So the project will get updated directly there. All right, perfect. I think that's all. Now, if you guys have any question, you can ask.
Yes, students, if any doubt is there, please ask.
You can ask any question. No question is dumb question or like that. Don't worry about that.
Sir, I have a question. Hello.
Seems like nobody have any question. The meanwhile, let's say, guys, if you want to discuss any of your project or like that, you can reach out to me at my email address. Let me just share that here. udemy@kgptalkie.com. Later on, let's say the offline, if you have any project or the idea you want to discuss with me on the generative AI or like that, or any other AI projects, then you can reach out to me at here, udemy@kgptalkie.com. That's my email address. Okay, seems like they don't have question, ma'am.
Yes. Okay. Okay. Thanks a lot, sir. Probably they might be going through the video recording.
Yes, seems like someone has raised the hand. Yes, yes, you can ask.
How to choose the best model as per your requirements? For example, which model for calculations and which for reasoning? Like,
Yes.
what are the parameters you should consider?
Perfect. Excellent question. Yeah. So you see, there are so many models available. Let me just quickly tell you here. There are models which are good in the reasoning. There are the model which are good in the coding. There are the models which are good in the math. So basically, you see, you have to see the leaderboard for each of the models. So how they are performing on these kind of the task. All right. Let's say if you want to select for the coding and open source model, let's say if you are looking for open source model, then you can come here and let me just show you here the Qwen 3 coder model. Recently it was launched. This is the open source Qwen 3 coder model. Where is that? Qwen 3 coder. Seems like I have selected some thinking or like that. That's why I was not able to see. Here it is. So this model performs so well than the other closed source model and OpenAI. So as you scroll it down, then you will see these leaderboards basically. So here you will be seeing all these information. Based on this, you can select. Let me just show you here. Cloud Anthropic model, that's the Sonnet core. This was recently launched that performs almost 70.4%. And they run their model on like, thousands, or you can say that tens of thousands GPU with the very high power. So much of electricity is getting used, and so much resources they have for this particular model. So that model have SWE bench. So this is like you can say that the benchmark where they test their model. So the accuracy is 70.4%. But the Qwen3 coder is alone giving here almost 70% accuracy. And then the good thing is here, this Qwen3 coder, I can run on my local computer itself. In fact, sometimes back, I was testing this Qwen3 coder model. Here, let me just show you here. In fact, it could be here, the Qwen3 coder model here. So this I can run on my computer itself, and its speed is so fast that it can generate almost 150 tokens per second. That is so fast, basically. All right, it is faster than. And I ask here the question, even the tough question, like the write code for the transformers. It can write the code for the transformers itself. So this particular model is very good for the coding. But if you use some other model which is not good in the coding, that model is going to give you a very worst result. So that is how you can select for a specific region. You can then find out for the model which are good in the reasoning for in a particular task. All right, you see here in very less number of, quickly it has written here the basic transformer codes like the positional encoding, multi-head attention networks, all these. So these are the important things in the transformers or the LLM. It has quickly written the code. In fact, some of these codes sometimes back I had copied it and tested it that the codes produced by these LLMs are so good that. All right, and to use these models, you have to pay like the $20 per month. But here with these open source model, you don't need to pay anything. You can use that as good as these models. And as you see here, the parameters, all right, the parameters are so less as compared to these models. All right, so this is the coding one. Similarly, you can get the models which have done the good. So you can basically search and then you can find out the technical report for those models. Let's say you want to find out the GPT-5 technical report. You have to search GPT-5 technical report. Then they might be giving you technical breakdown. You need to go with so many links to understand that where they have those things. I don't know if they have produced it. Generally, the publisher produces all the, these kind of things that how the overall the performance of the models on different kind of the scenario and all this, as you see here. So you have to go through with these report to understand that which model does good for which purpose. Seems like here they have here. All right. So for this particular competition, this is the math, right? So let's say for mathematical things, seems like the GPT-5 Pro is doing quite good as compared to the other models here. So similar to this, you can search and find out that for a particular things, how it is going to work. Like here, you can see the multi-turn instructions, then the agentic search, instruction following, all these things. All right. Any other question? Guys? Yes, sir.
Sir, in case we ask a particular model to reevaluate its response, what does it exactly do?
It's going to take that response, whatever it has generated previously, on given that it has the memory. So basically, LLM does not have any kind of the memory. What memory has here? The implementation has the memory. LLM itself is only the LLM thing here. So let me just quickly show you here that LLM is just the LLM. It does not have any kind of the memory. So the implementation which you are doing here, you have to maintain all the generated response, the previously response. What happened here? When you call it to the evaluate your previous response, then let's say if this is the previous response, then LLM will evaluate this particular response. All right. So it is like that. It's not just evaluating the previous response. You are like giving a text and then you are saying that, okay, this is my question and just see that this particular text is correct or not. So it is going to be like this only. LLM, as in LLM, does not have any memory. Only the implementation as a coder, how we are writing the code, that is going to have a memory. Does this answer your question?
Yes, sir.
Yes. Any other question, guys?
For giving the response from the previous chat. So for that also we need to do the same thing.
Yes, like this implementation, what you are seeing now, right? You have to do like so. But let me show you here. So this particular thing, if you have seen here, that this is maintaining the list of all the messages. All right. So this is like how the memory is actually maintained. Right. This is how it is done. Right. So you have the list of all the messages, and then you pass this to the LLM. So how this happens? Here you have there the dictionary where you have this messages, and in that you have a list. In the list, then you have your AI messages. Thereafter, in fact, before the AI, you have your user messages, which is known as the human messages. And then AI messages comes, maybe there could be the tool messages, there could be again AI messages, then again there could be a human messages. So this is how you maintain the memory. All right. So this is how you maintain the memory. Then what happened here? If this gets repeated so many times, it becomes like 1,000 messages. Then in that case, what happened? Your message might exceeds the overall LLM context. Let's say this is overall LLM context. Then if your messages are exceeding this LLM context, then you can apply some kind of the summarization techniques, some check pointers that okay, summarize first 1,000 messages and then produce just a single message just to get the gist. So like that you can do. Yes. Any other question, guys? Yes, Fras.
Sir, how do we ensure that our model is not giving us any like biased output?
That is something. That is something still in the research mode. People are not able to find out the correct answer for that. How we know that whether the answer is correct or not? But there are things which have been suggested previously to make sure that LLM generates the correct answer. So what we do here, we connect our LLM with our resource here. All right. So basically, we can say that the set of the documents here. So we connect our LLM with these set of the documents. So this whole process, what you see here, this whole process now known as the RAG. Otherwise, there is no way to know that if LLM is producing correct answer or not. So see how the LLM learns here. So whatever the data is used to train the LLM can generate answer based on those data only. If very high quality data is used to train the LLM, then LLM will produce the good answer, a good result. Otherwise, it will not produce. It will produce some rubbish things. So it depends, right? What type of data was used to the LM. But what happened? There is there is a thing known as like catastrophic forgetting or the forgetting. Like as a human mind, we learn so many things, but we forget a lot of things in that. So that is what the LM also does there. It learns so many things. It ingests everything in its weight, and then it tries to recall whenever we ask the question. But it's not guaranteed that it is going to recall everything correctly. The other thing, let's say if you want to figure out that the generated response every time, whatever LM is generating the answer, how natural that answer. So to know that, there are multiple ways to know that. There is a blue score. So generally we use the blue score. And other than the blue score, there is another score also known as, you can say that the rogue score is there. So these are the two type of score we use in our LM to know that whatever answer is generated, whether it is following a natural flow or not. But this score does not guarantee that how much it is correct. So correctness is not guaranteed. Yes, guys. Any other question? Yes, right.
Sir,
Yes.
sir, I have a doubt. A few days ago, I made a project using Gemini API. So
Mhm.
when I run some query, he hit API rate limiting very quickly. And in the
Yes.
documentation, it says that in 1 minute it can handle only 15 or 30 queries. or something like that. So how can I make that means run?
Yes, that is actually, you might be using the free version of Gemini there. So see, this LLM hosting is very costly. Companies host this on the thousands of the GPUs. There are millions of the dollars they are investing. So what they does there, they provide free version, but those free versions are very limited. So basically, you can call those in very slow rate only. You cannot call those so quickly. Otherwise, you will hit the rate limit. So to avoid that, what you can do there, you have to pay some price to them. So basically, you have to increase your tier usage. Otherwise, the free version APIs are like that. So it doesn't matter whether you use the OpenAI or the Gemini or the Grok or anything. Otherwise, you can then simply use the local LLM itself. No matter how you use, whatever the performance is available with your computer, you can utilize all those. All right.
Yes, sir. But even I use the Hugging Face to handle those query to get some API to run those system. Even that I handle the API rate limiting and something like that.
Yes. So see, are you using the free version or the paid one?
The free version.
Yeah. So the free version. That's why. That's what. Right. So the free version always have their the rate limit. Otherwise, see, if they do not, if they not put this rate limit, now then what will happen there? So anyone can use that free version APIs, and then they can use that in their product, right? Then why the people will buy the premium APIs, right? So that's why the people buys that premium APIs to avoid these rate limit and to get the better performance. All these things, like you see here in if you open AI, if you see here rate limit, so they have provided even if you pay through OpenAI, they had some tiers there. So like this only that the people have also tiers there. All right. So they have all these. As you put more money, then what they do there, they increases your tier. So usage tier basically. As your usage tier increases, you start getting faster and faster response. All right. Even though if you pay like let's say the $5 and you are in tier one and other people are in tier five, so the tier five have actually invested so much of the money. This tier five is obviously going to get more the quality response and the higher speed than the tier one and the tier two. That is how the everyone works, not just this OpenAI. All the LLM provider works in this way only. All right. So like they have these limits, right? Like rate limit 60 and like this only, right? The tokens limit, all these things they have. Okay.
Yes, sir. But even if I use open source model, so I have to run those in my local machine. But my computer is not that much heavy GPU.
So then in that case, then you have to buy there, right? Then these APIs you have to buy. You have to put some money there, and then you buy as you increase your tier, then you will start getting better and the better response. I mean, higher the speed. Otherwise, there is no way to get the higher speed.
Okay, sir.
Yes. Any other question, guys? Yes, Devin.
Sir, for getting response after searching across the web, so how we can do that? The LLM will give the response after searching across the web.
Okay, then you have to use the tool which have this search functionality. So LM will then perform the search, call the two search tools, and then it will give you the result. So for the search tool, you have so many things out there. Like you have Serper Dev API, I guess, is there which you can use. So they provide the Google search there result. Other than that, there is the EXA. So Exa search is there. They also provide this search API. So based on this, you make a tool. Other than this, there is the Tavily search is there. So you can use this one. Other than that, the free version is there. DuckDuckGo is there. Like this, you can use basically. All these things you can use here. All right. Okay. So all these you use as a tool, and then as a tool, you connect with your LLM like here. So you provide there one search tool, and then LLM will decide automatically that when it need to call that particular search. Recently, the Ollama has also launched the search tool, the Ollama search. Let me just see here that. Not this one, I guess in the blog, they have yesterday or day before yesterday, they have, yeah, I guess 2-3 days before, they have also provided this web search APIs there. So this is how you can use this search. There are so many actually. You will get like hundreds of the search API providers. Okay, guys, any other question? And in case if you guys are looking for the generative AI courses, then on this particular course page now, you guys can go here. You can watch these some of the basic courses for the Langchain and the Langgraph. So here I have covered these type of the question like you asked that how to get the real-time answer or the how to perform the search using the LM all these. So you can enroll in these courses. So these are the Udemy courses which covers from very basics Langchain, Ollama, Langgraph, agentic RAG, MCP, how you can fine tune your LLM with your own data, all this. So basically, how you can fine tune and then thereafter you can upload it on the Ollama, etc. Yes, guys. Any other question? Don't worry, you can ask the question. There is no question like dumb question. If I understand that many of you might have been feeling that ask, but you're not able to ask. You can ask that.
Hello, sir.
Yes.
So, what is difference between AI agents and MCP server?
Okay, so MCP servers are like the tools actually, right? So what you tool here you have now, so these are the actually the MCP servers, and the LM is the LM agent, right? So basically what happened here, nowadays what happened, generally we connect these LM and the tools together, we make the agent. But let's say if you have the MCP server, then how you can make these things? You can have your LM here, and thereafter you can have your MCP server here, and then behind this MCP server, you can have all the tools here. And like this, you can have many MCP servers basically. And all these tools are connected here. This is connected here. This is connected here. So all the tools are connected with this MCP. You need to connect your LM with this MCP and this MCP only. So now if you connect this whole thing together, now this whole thing will become your agent. All right, this whole thing will become agent. That's the one thing. The another thing what you asked here, the agent. In that respect, let me just tell you one more thing here: the difference between the MCP and the traditional ways to connect the tools directly with the LM. So if you connect your tool directly with the LM, in that case, you put your code, these tools and the LMs together. But in case of the MCP, what happened here? In case of the MCP, you can actually host your MCP and the tools, all these on a different server, and you can have your LM on a different server. So this is the major difference between the MCP. I mean, using your tool as the MCP or using your tools as your tools. The other thing here in the big companies, what happened here, if they have MCP, so they can assign a team to develop only MCP server, which are specialized in the MCP server. And then they can also have a separate team, which are specialized in the generative AI applications like the LLMs and the fine tuning. So this is the additional benefits of the MCP. Yes, guys, any other question? And in case if you want to go with the MCP course, then recently, I guess last week, I had published this MCP mastery course on the Udemy as well, where I have covered all the basics of the MCP, the references and some projects implementations and deployment, how you can deploy your MCP servers on AWS. Yes, any other question? Guys, ask your questions, right? Otherwise, Suja ma'am is not going to end this meeting before 7 p.m. You ask the question quickly. Just finish this. We could have ended this lecture like half an hour before.
Sir, by the response which we are getting, I think students really have few more questions. But as time permits, what I would suggest, students, you can post the message questions on chat, and Rashi, you collect the questions, and then we can mail it to sir. And if many are there, then we can arrange one more session if time permits with the speaker.
Right.
Okay, sir.
And guys, if
Okay,
you
ma'am.
implement some advanced projects, you want to have some discussions, so ma'am, you can also arrange some kind of meeting, maybe online or offline, to discuss their projects or like that only. Huh? Otherwise, my emails are there, udemy@kgp talk. You guys can also mail me your, the ideas if you want to discuss. I hope, guys, you have enjoyed. And the one thing here I know from you guys that you have asked the questions that shows that you guys have really good knowledge for the generative AI, and that is the good thing. Being as a computer science engineer, having the AI knowledge is good, because the people who do not know the AI in next 5 years, they are going to be replaced. That is for sure. People who learn how to use the AI, no matter whether they are computer science engineer or the salesperson or the marketing person, if they don't learn AI, then they are going to be like out of the relevancy after 5 years. You can think like in 1990 when the computer came, the people who did not learn the computer, then let's suppose that if they were the clerk or the supervisor in their early career, they retired from the supervisory only, right? They never progressed in their career because they resisted the computers or the mobile, etc. The people who quickly learned, then they actually moved in their career, moved ahead, right? And they invented so many things. So that is how we can also treat the AI. Someone has posted the question here, Athav, I guess. Are there any pre-trained model to work with the language translation purpose regional language in India? For Indian language, you can. I'm not sure exactly if there is any model available. We might need to search, but I guess recently some people have launched some model from the India itself. Otherwise, OpenAI is, or any other, the good models are very well and good enough to generate answer in Indian language itself. For example, even if we ask the question from our GPT OSL, this is open source model. Let me ask it here. Kavita likho Hindi mein. Let me just see that if it can write. I'm sure it will write here. This is just 20 billion model. It should be able to write the, yeah, you see here. So it is able to write here in Hindi itself, right? Or any other language, maybe Bengali. Let me just see that if it can write here Bengali. Yeah, it's able to write here in the Bengali. Guys, don't get offended. I'm going to write here the Marathi as well. Okay. I'm trying to learn the Marathi. Yeah, I guess it is correct. I'm not expert in the Marathi, but you guys tell me that if it is able to translate it correctly in the Marathi. I guess it is correct. So yes, these open source models are able to handle these, Indian languages. How Langsmith, Rohit asks, how Langsmith is used for AI agent management. Langsmith is not used for the management. Basically, Langsmith is like the observability tool. So whatever happens behind the scene, those things you can observe here in the Langsmith. So this is the only use of this Langsmith. Because see, once you develop a very large project, a lot of things happens in your project, and every time you cannot use a print statement like this. All right, every time that's not possible to print everything like this. So in that case, what happened here, whatever happens, that thing is going to get logged here in the Langsmith. Then you can come and you can debug your error or your problem. You can know all these things here. So that's the only use case for the Langsmith. Otherwise, there is no use case for the Langsmith. That's the only use. Yes, guys. Any other question? And with this, you can know that how much latency or how much tokens, all these things are getting used. Sorry, how much tokens are getting used. Yes, you can do. The JavaScript is also available, I guess, for the Langchain. Langchain JavaScript. I guess they have. Yes, they have here langchain.js. So you can use that. Like build simple LLM application. Yep, they have here. All right. You need to visit js.langchain.com. You can implement, and then you can call your tools and other things as it is, like as usual. Let me just post here for your reference. Yes, guys, any other question? Guys? Hello, knock, knock.
Hello.
Yes.
Sir, some of the SQL questions as you discussed, but the syntax of SQL questions are differing as per the database. So if you are designing function in any of the languages for SQL, like for triggers, stored procedures or functions, then syntax differs. So how those are handled by the code we written or the backend code?
You see, LLM is smart here, right? So we connected it with the SQLite. Now the LLM knows that this is the the format of the SQL queries. So that is why it has written that. If you connect it with some other the tools, let's say some standard SQL, right, where it has some a little bit different the pattern. So it will automatically identify based on the schema and the way you will tell in the prompt that you need to write the query in this particular language. So it will be able to handle that. So it has written that in the SQL because initially we had told our LLM that this is the SQLite data. And with the schema, it got to know that, okay, this is the SQL database, all these things. Otherwise, you can write the queries. Let's say if you have a Neo4j, the Cypher language you can ask. Let me just quickly show you here that I'm just going to ask here, right? Simple Cypher query to know how many employees are there in Neo4j Graph DB. This is Graph DB, right? Neo4j that uses the Cypher language. So you see here the simple Cypher language. So as we tell our LLM that this is the thing, it will automatically write in that particular manner. Let's say if you have your Neo4j installed and it executes this particular language, I mean, in this particular Cypher query, it gets the error, then the relevant error will be returned. And based on that relevancy, your LLM can recorrect that query again. I guess this answers your question.
Yes, sir.
Yes. Any other question, guys? Guys, you can ask or you can write. 16 more minutes go. So seems like, ma'am, now they don't have the questions. I guess then we can end this.
Yes, sir.
Okay, and I hope that all of you have stored all the link which I have shared here in the meeting chat. Just store those links and also, get the star. Seems like the 3 star. 3 people have started this project. I guess I was hoping that the more people will start this so that they can get the update. Anyway, so that's all I guess from my side, guys. As ma'am told you guys, you can reach out to ma'am and then they can collect, she can collect all the questions and then this can mail me. We can arrange some other meeting later on, maybe. Okay, thank you so much, guys.
Thank you, sir,
You're
for
welcome.
giving us time and sharing your expertise with the students. Thank you, students, for joining. We are ending the session.
All right, guys. All right, guys. Bye bye. Take care.